Cool. So hello and welcome to the first meeting in the to kick off the SIG Node reliability project, mostly to focus around improving the testability of the kubelet. We have quite a few people here today, which is exciting. So I guess everybody here saw my emails, but to go over and make a bit of an introduction about what I want to start with this is to start thinking about how we can improve the reliability of the kubelet, partially through testability and refactoring where necessary to make it easier to land changes in the future. Because where we are today, we have a lot of pretty scary regressions that land with basically every Kubernetes release where we land features in the kubelet. And to avoid us being in a place where we will want to eventually rewrite the kubelet, I'd rather us get the test coverage there today to make things, better for everybody and also easier for us to land new changes in the future. So let's see if I can share my screen. I apparently need to do macOS things. I cannot share my screen without restarting Zoom. So can somebody volunteer to share the document that I linked to in the email? Oh, yeah. Dawn, could you possibly share the document on your screen?
Daniel, I'll give it a shot. Give me a second.
I never used Zoom on my laptop. And so nothing works apparently. I gave you co-host Eric.
Yeah, I'm currently hitting the share screen thing here, and I'm having trouble just choosing one window to share. We're in double failure mode right now.
I love how I usually use Linux on the desktop and screen sharing is fine. And the one time I try using the just works operating system, can't even share a screen. Okay, so let's just go on assuming that everybody can see the document. The link's in chat if people are interested. So it's kind of a difficult thing to kick off. But what I want us to do today is to talk about the ways that we think we can improve the kubelet and areas where testing is missing from people who have experience with different parts of the kubelet. And then sort of define some goals for what we want to try and achieve in 125. Does that make sense? Cool. So Sergey gave us some notes that are a pretty good starting point that cover some of the problems we have with our existing basic unit test coverage and some of the E2E gaps that we have today, with some like specific things we're missing. But to quickly summarize that, we're basically, we have a lot of coverage. Well, the coverage we have today mostly focuses on the happy cases. So like we have a lot of tests that will assume that everything is fine or set up everything in a way that is guaranteed to be fine. But we don't really test what happens when things in the kubelet start to fail. Like we don't have any tests that cover, say, what happens if a CRI fails to respond at a given time. And we've had bugs in the past where, say, you restart containerd at the wrong time and kubelet will never like fully reconcile something, for example. And those are the kinds of things we don't really have any way to even reproduce in tests today. But I guess I'm going to open things up for other people to sort of talk about what they see as being major gaps.
Yeah, from a container runtime perspective, I agree. We did a good job writing the CRI API, but we didn't talk about enough what would happen if there's a context, failure, timeout on the client side or on the server side, and how that would affect, the overall solution. So yes, that definitely on each of the APIs, especially the primary ones like pod run, in container create and start, we need to go over in much more detail, the life cycle and what happens in these failures. It probably defined in the API, because we went on a how did we do it in Docker shim perspective when we did the container runtimes, but sometimes in the implementation there was a gap, a knowledge gap between what kubelet wanted or expected and what we were doing. Another place I think that's important to talk about here is the life cycle from release to release, the expectation of pods that can still be running after you've upgraded either kubelet or the container runtime or the runtime engine, right, or a virtual machine, yada yada, and even CNI, right? The expectation for that needs to be covered in some test cases. So I mean that's why I'm here. I think we definitely need to work in these areas a little bit. The bigger life cycle, as well as for each of the APIs, what happens if there's a failure, and it doesn't just hit kubelet. It's kubelet and cAdvisor, where we're still using cAdvisor for part of the solution for metrics and monitoring.
So my one thought here is maybe if we just kind of agree on what it means to be unreliable. And so I think historically, I would look at this as the kubelet is unreliable when it is violating a published invariant in the Kubernetes API. So the longest running issue I'm aware of that we've had intermittent challenges with is when a pod that is either incorrectly or correctly appearing to toggle between a terminal and non-terminal state, which seems to be the most common. I'm trying to think through, I don't know who else is on the call historically here. That in some cases has been a reliability issue at both the control plane side of Kubernetes as well as the kubelet data plane side. But for like our community as a whole, I think that to me is like a key thing, which is just like a thing that we could all agree on. Then there's subtler definitions of unreliability that I'm not sure how folks feel like when we mention like what happens when like a runtime restarts or that type of thing. It's clear that every system deployer of Kubernetes in some cases has made mitigations to those issues, right? Like even if it's at like the systemd unit file, like if your runtime restarts, let's just restart the kubelet to be safe anyway, right? Like these types of tricks can happen. And that in some cases is we haven't been clear about our own invariant of expectation there, but I don't necessarily know if we violated one, right? I think it's worth talking through. And then there's been like a weird squishy area in between where particularly on CNIs, where there's like expectations with respect to when the kubelet should communicate back to the control plane or not about particular state transitions that I don't think we've ever documented any expectations around, that I'm not aware of us actually violating anything with respect to what we've published. But I'm wondering if in this group we're looking on ensuring first we are meeting the invariants we advertise for, or are we trying to also maybe expand the set of invariants we want to give confidence around, like thinking about like when should the kubelet advertise back to a control plane when a pod has an IP address? That's like something we've never made any statement around. So kind of just curious as a group here if we can like, do we have a common definition of reliability there? But these are dimensions I could see us looking at. So
I have an idea about that, but I'll let Clayton speak first.
And then I'll keep this short. A couple of things I was thinking about, like as we went through some of the like cleaning up parts of the life cycle where we'd fix something and it would expose a bug or it would interact with another subsystem and then show up as another bug, kind of that same long like propagation. At that time, it was fairly easy to capture tests that would have caught the issue. But I think it's hard for us to keep a pipeline going of that and work through it. It felt, we could record it at the time we discussed it. There's a lot of really good discussions, and then they would die out a little bit. I think maybe one thing that I think this effort can really help with is that kind of collation and categorization of key test areas where we can try to do a little bit more to have a long thread. Most of the tests actually aren't that hard to burn through in batches, but they're actually really hard to context switch into and go write one and then come back 3 weeks later and write another test. So that might be a way to get, if we can start to build up some of those lists. And a second point, and I saw it kind of get hit, but it's kind of Derek's question about what's unreliability. A lot of the latent bugs, they're very observable in a large system where certain invariants are violated. It's super hard to pick out from a unit test or even a node EDE, where we would, once we knew what the problem was, it was super obvious. Seeing the problem was one act of filtering out reports from users that are of subtle things, or something that's, it's a small flake in a small part because we put the kubelet into a stressed state and we're trying a bunch of different things. I think there's a space, and I don't want to call it chaos testing, but there's a space for us to have a little bit more complex of a workload over single node without being all the way to a full system, or potentially, clusters that start in a specific state, like a lot of our performance and end-to-ends, like those kinds of variances show up. A lot of the pod shutdown, like where we would never clean up pods, they would just sit there in the kubelet. Those showed up because we had fairly strict, like, hey, why do some pods take 3 days to shut down? And so I think we can do a little bit better in that mid ground of a little bit higher than node EDE and a little bit less than full EDE.
Yeah, so like the way I was thinking about this is a lot of the kubelet today, we don't have a documentation of what our expectations are because there are no tests for a lot of things. And so it's less about whether the kubelet fails in a lot of like latent unexpected ways today, and more about giving us confidence to know that when we make changes in the future, we're not going to cause regressions. And so a lot of that is writing tests that essentially document those invariants. And then also introducing some of the like failure testing you were talking about into like places like gRPC interfaces and stuff. Where it's just like, a lot of stuff where we want to both introduce testing to like find latent bugs, but also introduce testing to stop us from shipping regressions. Or at least when we change functionality, know that we're changing functionality.
Agreed. And I think the invariant is a great way to frame it. The describing the invariants that should take place in the system are actually surprisingly easy to capture. It's certainly like on the OpenShift side, we spent a long time assessing, the sequence of transitions, and there's some really obvious ones that pop out. I think we can do a lot better. And this actually shows up in controllers in Kube, scheduler invariants, where we documented them, built Kube, and then never went back and really focused on, are we always satisfying our invariants? So I completely agree, Danielle.
I think the one thing I would say is part of the reason we are where we are, I think Clayton was the only one with the hand up.
As Dawn as well.
Oh, I'm sorry. The only other comment is like timing invariants have proven really hard to do. So like we were getting a lot of, one of the easy ways to fix a flaky EDE was to extend the timeout period. And the pressures of the infrastructure we were testing on were difficult. So like I'm wondering if there's a strong desire to try to maybe push timing invariants or timing guarantees here when we talk reliability, where I would kind of hedge on versus like behavior first and make timing stuff secondary. But I know I've written tests that I had to then later go back and push the timeout a little further because people's pressures on that given moment it's the easiest fix for the issue.
My take on that would be push for getting behavior tests in place. We can always fix timing later, especially when we start getting tracing in the kubelet and stuff. Dawn?
I think Clayton covered most of what I want to say. I just want to mention one thing. In the past, we did of the pod spec and auditing. So every pod related field and what's the variance we added test. That's a couple years ago. We haven't done that for last many years. So I noticed that many new feature, new field updated to the pod, and even there's the slight like the new value, new variance added. We don't have test specific, right? Especially for the non-happy paces. So we didn't add those tests. So I think maybe we can start from there. Like we did the pod auditing, so we added the first round of the load E2E test, but we are missing tons of things. Also, there are tons of the feature deprecated. We only simply removed the test, but we didn't realize, okay, remove certain tests because those tests may be tests that deprecate the field, but actually they have the more semantics we didn't cover. Another thing it is the couple years ago when we do that pod spec auditing, we said the next one we want to do the load level, and we never did the node, and we just ran out of time. Then we didn't continue. Then third one it is we do have like the stress test, but the stress test itself when we added always give us a lot of error, right? So because we are over stressed of the so people treat that it is we have the goal back then to make that is a little bit more reliable, right? So it's kind of like the how to make sure the because node E2E test basically try to remove of the uncertainty, right? Like try to remove of the scheduler. So it makes sure we try to make our node level test is more predictable. So like what's the input, what's the output? But obviously that's not the we didn't completely finish that one because still have the API server, we still have the control plane there, and we didn't guarantee of the resource for those because the node level of the problem. So stress test is never really run continuous. We have a lot of problem. actually, especially just you mentioned that earlier, you mentioned that unhappy path, right? You overloaded the node. And because we didn't test, those stress tests is being disabled, only manual run when people qualify Kubernetes, the new version, then will be running right. So a lot of things, there's the enhancement.
Maybe the last comment I'll add here is, in my experience, we've also hit reliability issues when we lack a feature or any reasonable sense of defense on the node, and then the kubelet is blamed for that source of reliability. So maybe just getting transparency among this group with respect to issues that I personally sometimes look at as best effort for the kubelet, but not like guaranteed. Like what the kubelet does in the face of disk exhaustion, I often view that as best effort, and I would want to get like consensus on if we all agree on that, because like disk accounting was slow, we lacked core features for it. IO contention I also view as best effort, and so like maybe just also clarifying like are those the unhappy paths that we want to tackle in this group, because they're often the root cause of an unreliability issue, particularly between kubelet and runtime communication, that I feel like we're defenseless at right now, and we should just be honest about that in some ways. Whereas the measured failure rate of pod lifecycle invariance being, you know, invalid is like a different thing, I guess. So I guess every one of us has had different experiences. Like sometimes I think we could overstate that there's like, in general, I feel like the kubelet is pretty reliable, honestly. It's just, this is an aspirational improvement. Like it's not like and I only state that because we have to kind of measure what we mean by reliable, right? And absent that measurement, like it's hard to focus our problem. I definitely agree on the testing side that there are areas that's ripe for improvement. And sometimes even in unit testing, I have found unit testing to not be as valuable sometimes when it came to the kubelet. And I'm also not sure if, as like an unspoken but expressed feeling here, is it the externally measured view of reliability or the internally confidence we want to gather as a community with respect to forward-looking changes? Because I can definitely agree that like there is confusion between like pod workers and the core kubelet iteration loop, that like, while it works and you could externally measure it, a dimension of reliability for it, it is confusing to many new folks that come in. And like I think back, Dawn, do you remember when I said to Vish, oh, we should draw a map or like some document that says how everything in the kubelet works? And at some point then there wasn't like uniform agreement that you even needed that. It was like, oh, let's just look at the code. It was obvious. So is this more a symptom of the latter than the former is what I'm also wondering, because a lot
definitely
of
a bit of both.
Yeah, okay.
Like we have the problem of like when anything touches that bit of the code heavily, we end up shipping either regressions or behavior changes that we don't understand, that are then hard to triage. So improving both like our coverage of how we test that, and also doing some level of refactoring to have better unit tests, as an example, mean that as we're writing and making changes to that code, we're documenting our assumptions about how that will work, and it makes it easier to triage those issues in the future. Because we're never going to not ship bugs.
Yeah, one broad area I could see that we also haven't covered is container runtimes are not always reliable in how they report back to the kubelet. And so that has definitely happened. And like our reliability is only as good at as the systems we invoke, I guess. And so just figuring out where we want to focus our defense a little bit. Like C-advisor metrics collection often stalls, right? I think we've all seen this. And you'll see messages like housekeeping intervals taking longer than 10 seconds or something. You're like, okay, well, at that point, the kubelet doesn't even have any idea what's going on this machine. And
I've seen that take an hour.
Right. But then and so exactly like this is very it's like a therapy session, right? And when a runtime reports back active context deadline exceeded, you're like, okay, well, the kubelet's defenseless here too. Or one list container call saying something exists and the next one saying it didn't. Like all these things can happen. And so I'm trying to understand, like, are we trying to look at total system here, or is it really to the point you're talking to Daniel, Danielle, which was a confidence in evolution of a core control loop, which I can totally get behind.
I will let David and Mike reply first.
I can go ahead. Yeah, I mean, totally agree with a lot of the discussion here. I just wanted to add one point that I think has been touched on, which is we also, I think, need to step back. We have tons of jobs and different variants of tests running today. And I think a lot of it has been a little bit lost, like what are we testing and why are we testing it? So, for example, what I'm trying to say is, for example, we have a lot of different variants, like different container D versions, different kernel versions. We have like cgroup v1, we have cgroup v2 that we both support. And so I think we needed to kind of step back a little bit and think, okay, like what are the valid configurations that we support, like on the OS level and on the container D level, and then exactly what tests we need to run. So for example, one of the big things that's coming forward is a lot of the OS distros are moving to cgroup v2 by default, but as a community, we probably still want to continue to support cgroup v1, right? So we need to think, okay, which test combinations do we actually care about? Which container D versions do we want to support, right? And what's kind of the policy moving forward where, okay, we always want to test this container D version with this image and so forth. So I think that's also something that has been a little bit ad hoc, especially like updating OS images and so forth, that I think we should define a little bit better. What is our policy and what we want to test?
We actually have an open issue for that, with some discussion going on, mostly between like me and Dims right now, I think. But yeah, like making sure we have cgroup v1, v2 parity, and then making cgroup v2 a default, for example, is something that I hopefully want to try and get done this release cycle. But yeah, we definitely need to document better, especially when it comes to stuff like cgroup drivers too. Like there have been recent bugs where like things work if you use systemd, but don't if you use cgroupfs.
Yeah, exactly. And so like, for example, we have, if you sort of multiply it out, you have like kernel versions times containerd versions times systemd cgroup drivers times like cgroup configurations. It's kind of a lot of stuff. So maybe it's not reasonable to test every single configuration. So maybe we should just say, okay, for cgroup v2, maybe we only support one driver. Okay, and we're only going to test that. Or making some type of claims around what we really want to test and support. I think it will be really helpful and important.
One.
Yeah.
Mike?
Backing up to the question that Derek had, or the point that he made about it's the container runtime too, right? I agree. And a part of it is the way we do parallelism in execution of, for instantiating pods and containers and pulling images, those sorts of things. We've got this director control loop in the control loop where kubelet's telling the container runtime what to do. And there's some expectation that these things happen synchronously without timeouts, but containerd will accept as many parallel requests that kubelet asks us to do right up to running completely out of resources and you getting timeouts on, these contact timeouts I was talking about earlier. So we have another model that we could provide that might be better and faster than doing the status update loop that we currently have right now, the sync loop. We could probably just push you guys over a stream some events that'll notify you of what we've actually changed in status, so that you can have a better expectation of what's happening in the container runtime, other than what you've asked for and what we've replied on, in the synchronous call, but becomes asynchronous when you get a timeout. Okay, Derek. So maybe, it's an architectural decision to go on that route, but we've got the events that from the execution of the containers, when they change status, we know right away, and we could just tell you that this container is gone or that this pod is ready, instead of you waiting to ask later on if it's still ready or not.
Sadly, reconciliation loops don't really mix well with event loops.
Yeah, and to be fair, Containerd is parallel in its execution much more than Docker was. So when you were in Docker shim and then you moved to Containerd, all of a sudden things changed a little bit, and we started accepting more of the requests than you would have been able to get before. Okay.
I think I'm the next one. Raise the hand here. So I agree with Michael. In general, you said here I think there's the one problem is that how Kubernetes integrate. I mean, not that integrate, but integrate with the container runtime. The whole integration test issues. We know this problem, so this is why when we do the CRI design and the implementation, so we introduce CRI test, but I don't think about we are proactively, not proactively, even just actively maintain those tests. We originally thought it is, we are going to continue add a new feature. Any new feature to Kubernetes, then a lot of feature will change of the CRI. And so we are going to have the test and the CRI test validate all the CRI implementation. So for all those SIG Node and the tests, we do have the CI test, even Containerd take over those CI tests, those as the pre-submit for sometimes. I haven't checked recently, did we still have that one? But I didn't see much of the new test added over times. And also even that time CI test, I remember back then, and only one engineer and work with me and Nanta we added. It's definitely not comprehensive. So we really heavily rely on the node E2E. But for the test, actually philosophy to really have the high reliability, you need mixed, right? So you need the failure test, you need the stress test, you also need the isolated environment for component test. I do think about in the container runtime, we didn't keep our promise. Before that, we do think about we are going to every single new container runtime and new version will actually have the suite of the CRI test associated. Then we publish those things. It's kind of like the conform test, what we did for Kubernetes, right? The similar thing for SIG Node, we feel of those kind of things. I have to say, we didn't change, we didn't add, even like a performance dashboard, we after a couple of years and we give up. So this is where a lot of time once a while we receive like, oh, container runtime for the new version, and maybe there's the using more resource and unexpected resource. And so those kind of things we definitely can be, it's not like we never did, it's new effort. It's just like the previous effort we already did that. We didn't actively maintain those, not a proactive even update request. We just didn't maintain those things.
Cryo and Containerd do both run Node E2Es on every PR list. And I think that helps catch a lot of stuff.
But we haven't, last time I checked, there's the new feature, we haven't proactively add any test. So the new version, basically, it didn't capture problem. Even like we found the container runtime problem, and there's the regression test, right? That's just engineering practice. We failed at the regression test there, right? We did hold on the node or like the Kubernetes level. When we have the refactory, then we found the problem, we add the regression test, but we didn't because I think people think about container runtime, it is another component, but actually it's owned by, it means the CRI, and the container runtime support the CRI, that interface is owned by SIG Node because it's our component. And that's our responsibility. We can find some compatibility or issue or all those kind of things. But that's I just want to point out because we do have the effort.
That's definitely something that should go on our list of things to improve as part of this. Clayton?
This is a response, but one of the things we were talking about reconciliation is, and to a little bit to Derek's point. So I am trying to clear out time to go and to document some of the flows that were touched, specifically around places where the kubelet invariants weren't handled because the control loops weren't accurate. The mission is a key part of that, which is there's a number of just the emission lifecycle does not resiliently handle changes to the kubelet well. So at least there is a draft kept sitting in my editor that is at least halfway of trying to document some of those assumptions. So that's something I'm trying to commit to get done. And I will certainly take feedback from folks around some of the other things I heard mentioned, like better documentation, better visualization of the flows, an opportunity for us to describe invariants, and where we should be doing reconciliation but are not, getting to a point where we can have some productive discussion on places in the kubelet that are sources of issues. So this is more of a side thing. It's just it is on my list of things that have not quite flushed to disk yet.
That sounds great. And actually super helpful. I am excited to read it. So I guess now we're starting to run out of time. We have 15 minutes left. Do we want to quickly sort of summarize the main areas we've identified and then prioritize what we actually want to do short term? Because it's open source, we have limited amount of hours in the day, an effort that we can actively do now, and sort of try and figure out what we want to do in the next release cycle versus in the next couple. I will take that as a sounds good to everyone. So if I'm remembering correctly, which it's getting late for me, so maybe I'm not, but we've basically identified the sort of few areas that I kind of thought we would, which is to say we want to document what exists today through our tests, but we also want to improve the testing that we have that has been underinvested in. So some of that is things like cry test and sort of like some of the contract testing around how we interact with CRIs, with a hopeful future case of potentially introducing some failure testing there, like a gRPC proxy thing that will just like randomly sleep or whatever. Like we can figure something out. Testing is always a bit dirty, but we'll figure it out. And then as like reviewers and approvers of parts of the kubelet start requiring that as we fix bugs and everything else in the future, we actually include testing coverage for them. Does that make sense as like the majority of what we were talking about actually being able to do now? Mike is nodding his head. Don, Derek, did I miss anything from either of you?
No, the one thing I was trying to think about how to ask is there are definitely features in the kubelet that are what I would classify as cluster workload specific, a cluster to a workload specific marriage of like desired outcomes. And those are often the ones that are not as extensively tested as we'd like, and they might use certain exotic or not, the 95% case of like resources. One thing I was curious about is if anyone has found reliability issues in those areas that we want to bring forward that like maybe none of us are aware of. So like if someone wanted to say like CPU isolation with the particular variant is just not working for me, or I'm seeing incorrect results with this particular workload, or entire features like huge pages with a particular page size is not working with me. I'm not aware of any of those. I'm just curious if there's anything in that realm or dimension that we should focus on, or maybe like kubelet plus a particular device we're seeing issues with, just so that maybe we can step back and ask, is there anything we can do as a broader community to get more attention to that area? Does anyone have any concerns or awareness of those things? I mean, as a vendor, I know we're using those in particular areas, but and so I only see what we see. I don't know what others are seeing.
The only one I've seen reported on Kubernetes recently is the one where cgroups v2, when using cgroupfs, something failed anything cAdvisor. But I think David has his hand up and worked on that.
Yeah, I mean, I wanted to add slightly different point, just like as a vendor also, like I think one of the biggest issues we see is like disk related. So like slow IOPS, slow disks, causing all types of issues from container runtime to kubelet to other things. Those are hard to combat because we don't have full control over the disk, but I think there's some things we can do. Like we've been looking at different IO schedulers, for example, and saying, okay, can we prioritize kubelet and container runtime over user workloads? So if a user workload suddenly schedules and uses up all the IOPS, we want to reserve some for the system. And that's something we're experimenting with, but perhaps doing that more as a community and figuring out kind of best practices around stuff we can do to provide more isolation to kubelet and container runtime, even if there's IOP pressure and disk pressure or something. I think that would be valuable.
I think that one would be super valuable in combination with like documenting the like permutations of stuff we support. With like, does the kubelet even require like explicitly a given kernel version? Like, not really. Like, if you have the features, it kind of work, maybe, but we don't document exactly what we need and when and where. And like, moving forward with cgroups v2, do we want to keep supporting running outside of systemd? Like, I'm not necessarily saying we don't, but like, it's probably a good time to have those conversations.
At earlier SIG Node, before we have even quality of the services, we have, at least we have the WOM score justified. Then we did some tests to make sure. And among all those jobs, is the workload job is being killed. At least the Kubernetes can do something. So that's those kind of things we still could, right? So for example, we have the Kubes reserve, system reserve. We could reserve bigger things and then try to see how effective we can avoid of the kernel sysworm, because that's really big loss. And right, so the Kubernetes, we reserved the save of the things, make sure Kubernetes could do something. So you could adjust those kind of value and say, can we really Kubernetes if customer configure Kubernetes properly, and Kubernetes can take action and to do the WOM handling. So those tests actually can help once we switch to the SIG version 2, and we have the better user NAND of the WOM handling, which is in the Borg. We propose that the user space WOM handling, because we think about we can do better job if we protect the load agent correctly. Right, so those kind of reserve enough for kernel threads, reserve enough for this absolute needed of the user space agent. Then what we can do? I don't think we put much thought. When I think about those E2E tests, basically I do think about that to generate a new idea, new feature. It's not that new because we already did in the past, but still, how we make that is generic enough for benefit the open source community. That's is much harder request because the community user actually is variety, right? So we have to provide more generic solution. So those kind of things. I also want to back to what Derek earlier asked. We do have customer cases once in a while. Ask CPU manager maybe not work as expected, but I think that a lot of things customers through other way and work around the problem because so those feedback might be not really bubble report back to the open source because a lot of solution next what we are trying to enhance of the CPU management and but the problem is customer cases sometimes is quite customized and so I think the open source solution actually is more generic. So customer after that, when they understand the CPU management, and they basically do some customized solution to work around those problems.
Yeah, and then maybe some other illuminating examples where we could publish expected variance. We've encountered node reliability issues in the face of exact liveness or readiness probes, where there's almost there's a misunderstanding with respect to how much memory an exec probe actually consumes from some of the underlying issues. Like I think run C, you couldn't launch something with less than a particular megabyte count, for example. And so we've seen systems where probe usage basically becomes like the dominant CPU and memory consumer on the node, and that's a surprise. And then that's also a surprise because we haven't actually done a perfect job. I think we probably vary by runtimes now. Who gets charged for a probe? Does the workload get charged for CPU consumption, or does it go under the system kind of charge? Similar things with respect to what can be the appearance of reliability would be, is an image pool confined to the pod sandbox that is trying to use that image, or is it the CPU associated with pulling that image charge the node as a whole? We've done things as a vendor to try to normalize those things for scenarios where that makes sense to normalize, and in other scenarios where it doesn't, like people can make different choices. But a lot of those things in my experience are like critical to actually keeping stuff reliable. And maybe we can do a better job of getting uniform best practice on some of that. But particularly with like kubelet is blamed when noisy neighbors cause problems, and rarely the workload is blamed. And so the more I know myself with my red hat hat on, I've been able to focus the problem on the workload and away from the kubelet, the better, I guess. But I'm curious as well as in the next discussion, if we feel like there's other things folks have done to better focus that. Because it all kind of goes into the reliability bucket, I guess. Trying to think of other examples.
Cool. It sounds like we have a big bucket of work we now know we need to do and agree that needs to be done, which is progress. When the recording for this is available, I'll go through and write up notes and start filing a couple of issues of things we want to think about. And then hopefully by next week's SIG Node meeting, we can sort of prioritize those a little bit as if they were caps. But Derek, is there something you want to add?
No, I was just saying it's very cool. This is good to see. Like, so +1.
Cool. So if everybody, does anybody have anything to add before we call it done? No? In which case, everyone gets, oh.
I was just lurking here, but I heard the one issue that is near and dear to my heart get mentioned without even posting it. So the liveness and readiness probes with exec. You spawn 100 probes that do liveness and readiness checks, even if they're just doing, you know.
Let's do it. Yeah, we need, honestly, guys, we need to change the probe architecture a little bit. We need to host in the container the ability to do a probe as opposed to.
For that one, Mike, I recommend catching up with some of the folks. That is actually a fundamental run C issue, right? And you run into limitations of Golang and our experience on this. So
yeah, I meant actually doing an exec for each probe. It creates a new process and a stream and logs and all that.
Yeah. So we've definitely done things to mitigate some of that,
Okay,
but it's not at the kubelet level is where I was trying to call out, and that the kubelet then gets blamed.
Yeah, it's a kubectl missing parameters in our implementation detail thing. Yeah.
Well, sounds like everyone's getting a couple of minutes back. So thanks, everyone.
Thanks.
Okay.